Hi, Joe Cerrone, and welcome to our Zoom meeting for CAD 230, Introduction to SolidWorks. Today, Module 2 is due September 21st at 11:30 p.m. Next week, Module 3. As we've done in these meetings, we basically open up the class for any questions that you may have. Zoom meetings are not required, but it's a good opportunity to answer questions and things like that. So if you're tuning into the Zoom meeting, great. This week, I'm releasing Module 3. Module 3 will be due next week, and it covers revolved and mirrored components. And so we'll model these 4 parts, and then this 5th one is bonus. If we take a look at the content section, in the content section, we're going to be going through Chapter 5. Chapter 5 covers revolves and mirrors, and then we'll be creating these 4 parts. There's videos for each of the parts. If we look at Lab A, Sebastian's gone through and done a great job with these. And he walks you through different things like closed profiles. And as we look at that, we'll cover that today. We'll take a look at that. I think I have latency on my computer because nothing's updating, so I'm going to go back here. There we go. So Module 3 covers these 4 part models, and then the last one's bonus. I have put the file for that right here, the solid modeling model.exe, and then you can download the Chapter 5 right here. I've already got it open, so let's take a look at that. So as we take a look at revolves and revolve parts, we're going to look at the difference between an open profile, which will create a thin feature, and a closed profile, which will give us a solid model. We really don't want this. These thin features don't give us any benefit to the modeling aspects of it. When we revolve something, a valid profile will be hollow like this. There won't be any areas that it can be interpreted incorrectly. There is ways that you can model it with closed contours. We'll look at that as we go into later sections. But ideally, what we want to do is we want to use a center line or a construction line, and then we want to have a closed profile for the part. And if there's more than one center line in the same sketch, we have to select which one to revolve it around. So as we take a look at the revolve parts, we'll start off with this ball joint arm. It's set up in inches, 3 decimal units. American National Standards Institute, ANSI. And then we'll take a look at these different relations and drawing tools. So we'll look at the sketch tool, lines, circles, rectangles, fillets, trimming, adding relations. Most of these we've already seen before. We're just adding this boss base revolve. As we start off with this project, we'll start off with the sketch. Note that the origin is located right here. And so SolidWorks likes to have the origin dimension to be able to create fully defined projects. And so as we create this, we'll create this geometry as it's shown right here. We'll trim this out, and then we'll add these dimensions. If we take a look at the file itself, here's our part right here. And I'm going to just get rid of the fade there. We'll make it plain white. And so we have this part. If we take a look at the base sketch by editing it, spacebar, normal 2. Here's our part. And I like to kind of move the dimensions, kind of clean it up a little bit. Sometimes it gets a little crowded in here. And as we zoom in, we can see that all the line geometry is black. We can see that's our origin. We can see our relations like coincidence. We can see horizontal relations, another coincident point. You can see that we have a tangent relationship here. If we wanted to remove a relationship, we can click on it and right click and delete it. And now you can see that we have lost that tangency relationship. If we want to add that back in, we can go in and say add relation. And then we select those two components. And then we can add tangent. I must have missed this one. Let's delete that one. There we go. Tangent, green check mark. And then it takes it a minute. Sometimes it stays blue for a minute, depending on the processing speed of your computer before it figures it out. So it's a fairly straightforward design. As we go into it, we can see that here's our construction line. When we work with construction lines, it won't try to create a feature out of them. So sometimes you can go and change over a certain element. So if I had a line that was drawn like that, while it's on the screen on this side here, you can define them or say that they are for construction. And then it will change them over to a construction type line. Let's delete it. Finish the sketch. So we create this sketch, and then after we have that sketch, we revolve it, and then we create a secondary sketch. And so if we look at the secondary sketch, and I like to hit the space bar, normal 2, we can see the geometry here. And as we look at the geometry here, it really wasn't super specific as far as like this end radius on here. So I don't think it's critical to the design piece. But as we go in and we start to work with this, you know, we could make any changes that we needed to it. But ideally, if we were to go back here and take a look at the textbook, we go through and revolve the part. We revolve it 360 degrees. And then we go through and we create a series of circles with a cordial relationship. And we have this line. Let's make that a little bigger. There we go. That's what I like about these PDFs. And so as we go in, we can see that both of these lines will have that cordial relationship, and then we'll create a 3-point arc on the end right here. And see, they don't really specify a radius on it, so I don't think they're critical with that. We'll make those arcs tangent to this radius. And then we'll make that collinear so that they are even with this part right here. After that, we'll revolve that 75 degrees mid-plane, meaning it'll go equally on both sides. And then we'll mirror that feature about the front plane. We'll add fillets, kind of soften that up so that it doesn't have these stress points, which will break easier, 0.080. And then we'll add some more fillets to the edges. That completes that drawing. If we take a look at it, we can see that here it is, selected as mid-plane. Can green check mark that. I'm going to hit escape, green check mark. And then you can see that we've softened that up with these other radii around the edges. And that just kind of relieves some of the stress that you can get on those parts as you become better with design. We take a look at the textbook again. Questions at the end of the chapter, those are just review. Let me take a look just to make sure I'm not missing anybody in the chat in the meeting. Looks good. You'll see these on the midterms and on the final exams. And the questions do give you the answers. And so as you go through them, you can take a look at them. A proper sketch profile for revolve features should be a single closed contour created on one side of the revolve center line. And that's true. And when they say one side, a lot of times people will draw both sides of a symmetrical object, and it only needs half of that. And we'll look at that as we go farther into it. If there's more than one center line, you need to select it. That's true. A revolve feature should always, no, it doesn't have to go 360 degrees. The sketch fillet command can also be used on solid features. Yeah, I believe so. To mirror a 3D feature, a plane or a planar surface can be used, should be. Yeah, you can do that. If we look at 5, yeah, true. It's nice to have the answers because we can check them. To mirror a series of features, a center line can be used as a mirror plane. I think so. A mirror, a series of features, a center line. Usually we want like, yeah, so 6 is false. We want a plane because we're working with features which are objects like that we've already revolved or created into 3D. Fillet feature is created, its parameters, selected faces and edges cannot be modified. That's false. You can modify your fillet features. So that's false. And then 8, either acts as a model edge or a sketch line can be used as the center of the revolved. And that's true. If we look at the flathead screwdriver, I really like this project because I can 3D print it. I guess it goes back when I was in high school, we had a metals project where I made my own screwdriver. I knurled the end on a lathe and then I created this component here and filed it down and welded it. So as we look at this component, again, you know, it's basically a pretty straightforward exercise. As we go through, they'll give us the overall dimensions. It's 5.5 inches. And then the handle is kind of squared off. And so they'll give us kind of the basic overview of it. And then they'll show us how to draw that. And so our baseline sketch is this 5.5 inch long geometry. And you can see this is where the origin is located. And then we go straight up, slight arc, straight over. And what I did is I just created a circle and then I trimmed it out and then I filleted it to create that geometry. Same with this area, I created straight lines and then filleted it with 2D geometry. So if we take a look at that, here's my screwdriver. And then if I go and I look at the sketch for that and I edit that, spacebar, normal 2, we can kind of see how that geometry is set up. And so here's the origin. We come up with a straight line and we arc it, bring it over, create the rest of the geometry. And it's fairly straightforward, this component is. Sometimes you'll get into some trouble where as you draw things, you should be kind of getting an idea of the approximate size. You don't put them at the exact size. I have seen people who will do that. Like they'll draw a line like this and they'll say, oh, I want it to be 1 inch. And so they'll go into this area right here and they'll say, make it 1 inch, 1.0. And that's fine. You can do that. And then when you put the smart dimension on it, it will tell you it's exactly 1 inch. But you don't really need to do that redundant process. This is enough by putting the smart dimension on it. And it'll always be blue until we actually locate it from the origin. So if I wanted to get something fully defined, I'd say I have to go to the origin here and put one dimension on here. And let's just make that 1 inch too, just for the grins. We'll say okay. And so now we're fully defined with that line. As we go on, let's get rid of it. I was afraid I would do that, but it's okay. Delete it. And so our sketch is completed by hitting the green check mark. And then we have these cut extrudes. And the cut extrudes, when you look at them on this edge, let's edit that. There's a couple of ways to do this. I had some trouble when I did this. And so what I actually did was to create like a triangle like this that would go about it. And then I would just extrude cut each edge. So if you do have any difficulty with that, you can also create the geometry, the negative geometry to be removed. And so that's that component, not too difficult. And then if we look at the back side of it, we have it right here. Oh, I'm not fully defined. Space bar, normal 2. And then as we look at it, we can see, that there's a few geometries here that aren't fully defined. Well, how do we fix that? Well, one way is to right click in there and say fully defined sketch. If we say fully defined sketch, then what we want to do is we want to select a line. And I prefer to do one entity at a time, and I'll calculate it. And then I'll green check mark it. And see, by defining that one line, all the rest of them kind of got in shape. And if we undo it, we can kind of see what it did. It looks like it put that 0.005 dimension on there. And I could probably put a smart dimension on it from the origin to here, and it'll do the same thing. Yes. And so its solution and my solution similar, but not exactly the same. And so what we do here is we have this rectangular shape, and we linear pattern it, or we circular pattern it. And then we use that to kind of cut through the handle, and it just kind of slices through it. And so if we go through and we okay that, you can see, and if we wanted to look at it, if we wanted to edit the feature, we can go and say edit the feature, and then we can see how that is. It's gone up to surface. We could go through all, there's a number of different ways that we could do that, and it'll still work. If you want, you can go through and add some industrial design, some highlights to it. I like to color things. So if I were to go in here and say, oh, the cut extrude, let's make that green check mark on that. And then if I want to do some more coloring on it, maybe I'll go through and right click in here, clear the selection. And then you can expand this part of the menu tree, and I could say, well, let's make the fillets. And so we'll go to features here, fillets, and then I'll say I want the fillets to be silver, green check mark. And I could say make the overall part if I wanted to. Let's make the overall part. I don't know. I think we'll just leave it that gray color. We'll say okay with that. So I guess my fillets should be changed to a different color if I want to do that. And so we'll go back here, clear this, come back here, fillets, and then we'll go with blue. If you want to put your name on it, okay, and you're 3D printing this and everybody else is 3D printing it, what we would do is let's get an isometric view to it. I would choose a plane, and then I would start a sketch on that. I hit the space bar and I'd go normal 2. You don't have to go normal 2, but you can. And then what I would do is I would make a center line for where the text is going to be. So I'll say like that. And then once I have that, I'll green check mark that, and I'll go to the A here, the text tool. And then it knows that that's the line I want to put that on. You can also put it on curves. And then I can put on there CAD 230 SolidWorks. Now, if it's too big, if I need to make that smaller, you can go into you can uncheck use the document font. And then what you can do is you can update the font here, and you can just dial down the units a little bit. And so I can say 0.1, and then I can okay that. And then if you want to, you can extrude cut it. And so I can go to features. So I'll engrave my name on it, and I'll say extrude cut, and I can bring that in 0.05. That's a little much. Let's go with 0.02. Perfect. A 3D printer will put down a layer about 0.1 to 0.01 to 0.03, depending on how we have it set up in the tolerances. You can do more with this if you want to. You can add fillets to it. So if you wanted to get something a little softer, you can get a very fine 0.00. Let's go with 0.010, 10 thousandths. It might not be enough to do it. I think it's too small. 0.005. Yeah. So I'm kind of pushing it a little bit here, but it depends, what you're into, how far you want to take your design elements. I'm going to bail on this one. I changed my mind. I don't like it. So I'm just going to hit the X on it. There we go. All right. So that's the screwdriver. And that's a basic rundown on how to create that part. Kind of like the new one. So I'm going to save it. Do a save as. It will update to the 2021 version. Say yes. Sure. Go ahead and replace it. Yes, I know. Older versions. And then as we go through, again, some of the relations, I just had to add one to fully define it. And again, you can right mouse click in it. And so here's another exercise with this derived sketch. And essentially, we're going to be able to then take that sketch from the center line, revolve it, create a new work plane. And as we create these work planes, you can set up the offset distance for it. And so let's take a look at it. And we can go into our initial revolve. Here's our second work plane right here, this second peg. If I wanted to make a work plane, let's just say I wanted to see some of the planes. If you right click on the plane and you hit the eye, you can show them. And then if you hold control, this is kind of a shortcut, but if you hold the control key and select a plane, you can drag off a second plane on it like that. And then you can set up the offset distance on that, like 0.5 if we needed to. And then you can work on that sketch or on that plane. So on the derived sketch, we create this secondary sketch, revolve it, add the fillets, and complete the part. Okay, and so lastly, there's this wheel. And as you go through and you create the wheel, you only do half of the geometry to be revolved. And so as we start to look at the geometry, we'll start with the front plane and we'll start off by drawing this. And they use this dynamic mirror. I'm not a big fan of it. I'll typically draw half of it and then I'll mirror the other half. They put this little arc on the end of it. And then they start to go through and add these other relations to it. And then they revolve it about this center line and add the holes to it. So if we take a look at mine, we can come back here, go to our sketch, and edit that. Spacebar, normal 2. And so here's our sketch. Here's our center line. And then what we've done is we've revolved that. Once we have it revolved, we can go in and then create another sketch to add these extrude cuts like that. And then just add the fillets. The last one, the plastic bottle. I believe Sebastian has that one in the videos. This one's not required. It's a bit challenging, so make sure you have some time to go through and do it. I'm not going to go through and do that one today. I'm getting kind of to the limit of my Zoom meeting before I open things up for questions. But it's a really nice project. As you go through it, you model the bottle and then you put some threads on the end of it, some fillets, create this pattern, shell it. There it is. And we do a helix. This is the old way of making threads. They have a thread wizard, which is quite nice, which we'll look at in future videos. And then what you'll do is you'll sweep a thread geometry along that contour to create the cut. And this is how tools are in the machine shop on a lathe. They'll have a 60-degree cutting bit that'll make the geometry for the thread bit, for the thread. And you'll have to know what the pitch is and turn that into the feed and speed rate. But what's really nice about working this on CAD is that you can 3D print them with the threads and test it out. So that's the exercises for this week. Back to the main splash page. Back to the main. So module 3 is due next week, and then we'll just continue on into module 4 and 5. I am working with the quizzes. If there is any difficulty with the quizzes or anything, just let me know and I'll update them. I think I have most of them fixed. I didn't change anything on the first one, but I've had some students say that there was some difficulty with it, so I will enable some additional attempts for that. All right, with that, I'm going to stop the recording, and then I'm going to open things up for questions.